Is it true Earth used to take 420 days to orbit the Sun? You might have seen the claim online, and it's at least partially right, but it's not the only other number of days Earth has had. The Earth used to have 420 days a year, rather than 365. This does not mean that the Earth's orbit was longer, but that the days were shorter, so more days could be fitted in during the time it took our planet to do a full orbit around the Sun. However, the year has had a lot of other numbers of days at different times, so it's worth looking at why that is, and also why the 420 figure is the one referred to most often. The spin of the Earth is gradually slowing down, although with brief periods like in the next 2 months where it speeds up, against the trend. That means the days are getting longer, and there used to be more of them in a year. Towards the end of the dinosaur era, there were 372 days in a year. When the Earth was first formed, it probably spun fast enough to fit at least 500 days in a year, possibly many more. There were no sudden jumps, with 450 days one year and 400 the next, so over time we've gone through a lot of numbers. So, why do a lot of articles refer to 420 rather than any other number? Hopefully it's because it's 10 times the meaning of life, not for the other reason. Before discussing why, let's look at why the days are getting longer. All about the moon. The planets spin at very different rates. Jupiter takes 9.9 Earth hours to complete a rotation. Venus, 243 Earth days, longer than its year. These speeds are generally a product of the angular momentum of the protoplanetary cloud that formed them. As far as we are aware, most of them haven't changed their rate of spin much since formation, although there may be exceptions. The Earth, however, has slowed down a lot, which we think is mainly because of the moon. Although not the largest satellite in the solar system, the moon is unusually large relative to its planet, particularly since Pluto's demotion. That means it has a considerable geographic influence on the Earth, slowing it down. There is a constant amount of angular momentum in the Earth-Moon system. If the moon moves further from the Earth, which it is doing, then that increases its angular momentum, which is calculated by mass x speed x distance from the point around which it is moving. Extra distance more than compensates for the loss of speed, so the moon carries more angular momentum, and must have gotten it from somewhere. The only available source is the Earth's rotation, which has had to slow down. The reason the moon is moving away is the tides. Both the ones we see in the oceans and the smaller tides the moon raises in the Earth's rock. The gravity of the moon pulls the Earth towards it, causing a bulge. However, friction creates a delay, which means the bulge is slightly misaligned with the Earth-Moon axis. With the moon out of alignment, it exerts a torque on the bulge it created, slowing the Earth down and pushing itself away. The lost days. Since the moon has been with the Earth almost since our planet's formation, and has been slowing it down all that time, we've had a lot of days of different lengths. However, working out how many days there were at a particular point in the Earth's history is not easy. For at least half the Earth's lifespan, we can do little more than guess. Some researchers have calculated that 1.4 billion years ago, the day was about 18 hours long, implying a 490-day year. However, their methods assume the processes lengthening the day have been relatively constant. More recent work challenges that. It argues that from 2 to 1 billion years ago, the Earth's rotation barely changed, which the authors attribute to the Sun's influence speeding up Earth's rotation, via the atmosphere counteracting the moon slowing us down. If this work is right, during this immense sweep of time, the Earth had a year of around 460 days. More recently, corals have helped us out. Like trees, many corals' growth coincides with the seasons. This leaves a record of different colored seasonal growth, like tree rings, allowing us to determine their age. Within that, however, some shallow water corals also record high and low tides, and the sediments they are exposed to. In 1963, Professor John Wells of Cornell University published a groundbreaking paper on fossilized corals from the Middle Devonian, 380 million years ago, which reported a 400-day year, give or take a week. Others have followed Wells's work, finding that during the 419 million years ago, the Silurian period, the figure was between 400 and 420 days. That makes sense. If the number of days was getting longer the further back you go, a point about 40 million years before Wells's estimate should be in that range. The high end of that estimate has then been quoted a lot online. If this is the case, then, before the Silurian, days would have been even longer, but without a lot of ways to measure it, we don't know how much longer. So, the 420 figure has stuck in popular debate as the largest number we have, from the furthest back in time. Not everyone agrees with it, however. In 2000, Dr. George Williams of the University of Adelaide published a paper that used the same technique on a much older coral sample to produce a figure of 400 days, 620 million years ago. As he notes, this contradicts Wells's work, and even more so the figure of 420 days from around 200 million years later, and he explains why he thinks he's right and they are wrong. Williams also uses some different techniques to get estimates of either 466 and 514 days to 450 million years ago. As you can imagine, with such different estimates, not everyone is sold on his conclusions. With qualified scientists reaching competing conclusions, IFL science is not offering a conclusion about who is right. What everyone, flat earthers and young Earth creationists aside, agrees on is that the days used to be shorter, so that at some point there were 420 in a year, as well as 400, 450, and probably 500. Quite when those were is a matter we'll leave to others.